So typically this first part of our notes today, we usually use as like a warm-up as a full class. However, you guys should have completed this prior to today's class, so that way you guys can hopefully kind of use this as a refresher. So first off, what you guys see on mine, and I just give you a quick answer key here. We're going to talk about it briefly, but not go over the entire thing, is what you see in red in both of the graphs are your parent functions. Now notice that I did change my scale. Here, my 1 is at that just up 1 and down 1 mark, whereas over here, my 1 is technically up 2 and down 2. So I changed my vertical scale just a little bit. That's totally fine. The big key for this is here, this is going to be vertically reflected and also stretched by a factor of 3. So in other words, what was once down 1 is now up 3, and that's the case throughout the whole thing. On the flip side, this is going to be vertically compressed by a factor of 1/2. And so instead of going up 1, I'm going up 1/2. And instead of going down 1, I'm going down 1/2. Okay, so here's the deal though with this. Your amplitude we've talked about prior is still 3, even though it's a negative out in front. Don't forget your amplitude is a distance, so therefore it's the absolute value. And then the second one, your amplitude is 1/2. So hopefully you guys got those. The ones that I want to spend a little bit more time talking about are these, and this is connecting it back to our previous knowledge with regards to horizontal stretches and compressions. And so when you look at the first one, remember, you want to think opposite. So if it's connected to your x, even though it appears as if this is divided by 3, you're thinking opposite. So it's going to be multiplied by a factor of 3. Okay, whereas this one is on the outside, so it's affecting the vertical. So as we look here, your 2 is attached to the x, so you're doing the opposite. So instead of multiplying by 2, you're actually multiplying everything by 1/2. So if you look here, instead of going pi over 2, you're cutting that in half to go pi over 4. Instead of being over pi, cutting that in half, and you're going pi. So if you think about it, it makes sense that if your period of your original was 2 pi, your period of your new is going to be half that because it's been compressed by 1/2. Whereas if you look at the next one, your period here is going to change. But if you look at this, the reason why, if you do x divided by 4 in that sine area, you're thinking the opposite. So everything is going to be stretched by a factor of 4. So here, pi over 2 point is going to move all the way over here to this 2 pi because pi over 2 times 4 is 2 pi. So as you look at your periods, it's going to be directly connected to whatever is going to be connected to your x. So for example, here, what are the periods of the previous two functions at the bottom? This, or the original period, is 2 pi, but because everything has been divided by 2 or multiplied by 1/2, that is going to then affect your period. Same thing here. Your original period is 2 pi. Since everything has been multiplied by 4, that means that's where your period of that should say 8 pi, not 8x, where the period of 8 pi should come from. There we go. Change that. Okay, so as you guys are looking at this, it's the same concept. It's just now being applied to sine and cosine. So don't make it something new. All right, so when you look at this, the frequency at the bottom, this is a new term. The frequency is just the number of complete cycles a wave completes in a unit interval. Okay, that sounds kind of tricky if you ask me. Here's kind of the more condensed version. It is just the reciprocal of the period. Okay, that is how you are going to find it. That is kind of, for me, that's kind of where I settle in to figure out your frequency. So as you look at your general summaries, okay, on the back there, your amplitude, you are pulling that from the front. That is a review. It's the absolute value of that number. Your period is going to be directly connected to the b. But if you notice there, it's b times whatever is connected to your x. Notice because it is within a big set of parentheses, this is still technically connected to the x because it's following that sine function. So the period in our equation is multiplied by, or that is multiplied by b, so our period means that it's going to be divided by b. Now, sometimes that b is negative, so we're going to actually divide by the absolute value. Again, we're going to try to make this as simple as possible, so please don't stress about that. And then if your frequency is the reciprocal of your period, it is going to be the absolute value of b divided by 2 pi. So it's just the same thing as a period, only flipped. Okay, so, and again, guys, one of the reasons, let me just talk briefly about this. What this is basically saying is in 1 unit, you've gone 1 over 2 pi of the cycle. Okay, let me say that again. In 1 unit, you've gone 1 over 2 pi of the cycle. So that's why that idea of the reciprocal of the period kind of connects to frequency. But again, if you can remember that the reciprocal of the period is how you find the frequency, that's the main point. Okay. Now, guys, we're going to do these together. All right. We're going to, especially the second one, we're going to take our time on. The first one hopefully should be fairly easy for us. What we're going to do to start is we're going to go ahead and just kind of give a quick sketch of the sine. So remember, sine starts at 0, 0. It's going to end at 2 pi. And so that's 1 full cycle. Halfway through that, it's going to cross that x-axis again. And then I'm going to change, or excuse me, I'm going to leave my y-axis as units of 1 because I'm going to be stretching it by 4. I'm going to look ahead a little bit. So I'm going to go up 1, down 1, and then same thing over here. Halfway is where that x-intercept is, and then up 1, down 1. That's my parent function. Now, when we look at this, let's pick apart what is happening. Okay, we have an amplitude of 4 because of this. Okay, so I'm going to go ahead and fill this in, an amplitude of 4, but it's been vertically reflected also. Okay, so it is going to be reflected and stretched by a factor of 4. Okay, I'm just going to put that there. We also know it's going to be vertically stretched by a factor of 4. Here's the key. What I would suggest doing is I would use this to find my new period. So again, think about the opposite. Right now, this is what it looks like, and I'm just going to put this kind of in a think bubble. It's 2/3 times x. Okay, if you kind of pick that apart. However, remember, we're doing the opposite. So that period is going to be 2 pi times, okay, my original period is 2 pi, times, and then we're going to do the reciprocal because, again, dividing by 2/3 is the same as multiplying by its reciprocal, which means that my new period is 3 pi. Okay, so if you think about extending this, if my new period, I'm going to do this in this kind of obnoxious green color. If my new period is all the way out to 3 pi, this point here is going to be stretched out to here. Okay, so I'm going to actually erase that original green so I don't get confused. But my pi here is going to be stretched to 3 pi over 2. Everything is going to be multiplied by 3/2. Okay, and then the same thing going the other direction. This pi is going to be multiplied by 3/2, taking this to 3 pi over 2. Okay, this is still going to be 0. So I'm just doing my x-intercepts. I'm doing the horizontal stretch. So I'm multiplying everything there by 3/2. I'm not too worried about the in-between points, and you'll see why in just 1 second. The other part is we know in our original parent function that our peaks and our maxes and our mins are halfway between my x-intercepts. Okay, so as I look at this, I can use my x-intercepts to kind of figure out that halfway point. So if I look at this, 3 pi over 2, I can look 1, 2, 3, 4, 5, 6 units to get there. So that means 3 units away is my halfway point. And instead of going up 1 to get to this, I'm actually going down 4 because it's not only stretched but also reflected. So 1, 2, 3, 4. Okay, so now I'm going to erase all these little green marks so I don't get confused. All right, and then over here, again, I've got 6 units like in between those 2 green marks. So the halfway point is going to be the 3 mark. So 1, 2, 3. And instead of going down 1 like we did originally, we're going to go up 1, 2, 3, 4, and it's going to look there. And so now my graph looks something like that. Okay, we've already figured out that the period is 3 pi. Okay, so we can go ahead and just bring this down. The phase shift, in other words, the horizontal shift, we haven't shifted left or right any, so this is none. And the vertical translation, we haven't talked about either one of those yet, so that is also none.